Yes, today what we're talking about Unit 7, Lesson 5. Okay, we're talking about today the trig ratios in right triangles. Previous to this, we've talked about specific right triangles, which were 30, 60, 90, and 45, 45, 90, where the trig ratios have special values or simple values. Okay, we're also going to use word problems or talk about word problems that are using trig. Okay, so here's what we got. We've talked before. We have three primary trig functions or ratios that we're going to use in geometry class. These are the sine, cosine, and the tangent. These were given in the previous two lessons for the 45, 45, 90 and the 30, 60, 90 triangles. And we also talked about the values for them in those angles. Okay, the ratios that we talked about are still going to be used, and they're used in the general case like we're going to use today also. Okay, so the sine of an angle is simply defined as the opposite leg from the angle that we're talking about divided by the hypotenuse of the triangle. So if you look at the diagram, angle A is the angle we're talking about, so the opposite leg in this case is going to be the leg BC. Okay? The adjacent leg is going to be the leg AC, and the hypotenuse will always be AB in this particular case. Okay, the next ratio is the cosine, and the cosine of angle A is always defined as the adjacent leg divided by the hypotenuse. And then lastly we have the tangent of A, which is the length of the opposite leg divided by the length of the adjacent leg. Alright, so these are what we have. So the assumptions that we're using here are simply this. A is one of the acute angles of a right triangle. B is also one in this case, but we're restricting our talk here about A. The same thing could be said about B, but then we would restrict A out of it. Okay? So the opposite is the length of the leg that's opposite angle A in this case, and so the length of the leg that's opposite angle A is the length of the leg BC. The adjacent leg is the length of the side that's adjacent or next to angle A. In this case it's AC. Okay. Hypotenuse, or HYP, is what the abbreviation is. That's the length of the hypotenuse, which is AB. Okay. Alright. In geometry, or the course that we're currently in, we're going to restrict ourselves to the three trig functions we listed above, the sine, cosine, and tangent. There's three more, and the other three are simply reciprocals of the main three, and they are called the secant, which is abbreviated SEC, and that's the reciprocal of the cosine, the cosecant, which is abbreviated CSC, and that's the reciprocal of the sine, and the cotangent, which is abbreviated COT, that's the reciprocal of the tangent. So the reciprocal of the cosine, or the secant, would be the hypotenuse divided by the adjacent leg. The reciprocal of sine, or the cosecant, would be the hypotenuse divided by the opposite leg. And the cotangent, that's the reciprocal of the tangent, that would be the ratio of the adjacent leg divided by the opposite leg. So as you can see, they're just the same thing in a different form. Okay, but we typically will not use those, and that's why you don't find them on the calculator. Okay, to find the trig function of any angle besides 30, 45, or 60, it's usually helpful if you can use a scientific or graphing calculator. If you don't have one of those, the other option that you can use is a table, but tabulation is less exact than what you can get with the calculator. Then you have to use a process called interpolation that we're not going to discuss any further than that. Okay, example 1. You use a calculator. This is what they want you to do here. So they want you to use the calculator to find these trig functions in problems 1 to 3. They want you to round them to 4 decimal places, and that's always standard when you're talking about the values of these ratios. So when they tell you they want you to find the sine of 23, you need to go to 4 decimal places and round it to that. Okay, so if you put it in the calculator, you're going to get that the sine of 23 is approximately 0.3907. Example 2, cosine of 79.2 degrees. So you press the cosine key, enter the 79.2, close the parentheses, press enter, you get 0.1874. Okay, example 3, they want us to find the tangent of 51. Okay, so tan 51 comes out to approximately 1.2349. Okay, one thing that I do need to mention at this point is before you use any of these with the calculator, especially the TI-83s that we have here in my class, you must use the mode key to go find out and see if it's set in radians or degrees. If the calculators have been reset for whatever reason, they will always default to radians. So you need to make sure you check it before you use it to do any kind of calculations like this. Okay, example 4. This is an application of it. They want us to find the trig function to use, or they want us to use a trig function to find x in this diagram. Okay, if you notice here, x is the length of the leg that's adjacent to the 22-degree angle, and 5 is the length of the leg that's across the triangle or opposite the 22 degrees. So since we have the opposite leg and the adjacent, and we're looking for the adjacent leg, then we need to use the tangent ratio to find this. So we simply set this up as the tangent of 22 is equal to the opposite leg divided by the adjacent leg, which is equal to 5 divided by x in our diagram. Okay, use the calculator to find that the tangent of 22 is 0.4040, so we set up that over 1 is equal to 5 over x. Cross multiply gives us 0.4040x equals 5. Divide both sides by the 0.4040, we get x is approximately 12.38. Okay, example 5 is going to be using the same thing with a different triangle and a different leg or a different thing that we're looking to find. So our diagram this time shows us that we have a 67-degree angle, and the leg that's opposite the 67-degree angle is 7.1, but the x is representing the hypotenuse. So since we have the opposite leg and we're looking for the hypotenuse, we're going to use the sine function. So sine 67 is equal to the opposite leg divided by the hypotenuse, so in this case it's 7.1 divided by x. Okay, we set that up. We use the calculator to find the sine of 67, which is 0.9205. Cross multiply gives us 0.9205x equals 7.1. Divide both sides by 0.9205, and we have that x is approximately 7.71. Okay, example 6. They want us to use a trig function again to find x. So let's see what they gave us. They gave us an 18-degree angle, and they gave us the leg that's next to the 18-degree angle, so that's the adjacent leg, and they gave us the length of the hypotenuse. Okay, so since we're looking for the adjacent leg and we have the length of the hypotenuse, then we're going to use the cosine. So the cosine of 18 is the adjacent leg length, which in our case is x, divided by the length of the hypotenuse, which is 89.5. Okay, so we find the cosine of 18 in our calculator, which comes up to 0.9511. Set up our proportion, cross multiply, gives us that x is approximately equal to 85.12. Okay, for a word problem, what you do is you simply, if it's using a right triangle, you draw the triangle, label the sides, and look and label the side that you're asked for as some variable, either x, h, or whatever makes sense in your problem, and then you solve it just like we did in the previous examples. Example 7 is one of those. Okay, so you have an observer on the ground that's 300 feet from the base of a building. He measures from his position an angle of 36 degrees to the top of the building. If the angle is measured with respect to the ground, what is the height of the building? Okay, so here's what we're talking about. We're talking about that you've got a right triangle that's formed by the observer, the building, and his line of sight. Okay, the line of sight, because they said that he had to raise his head 36 degrees, or his eyes 36 degrees to see the top of the building. That means that what you're looking at here is that's the angle of elevation. If he had looked down 36 degrees, that would have been the angle of depression. Okay, but either one of these work exactly the same way. It's just a matter of which way he's actually looking. Okay, so first thing we need to do is to draw a diagram. So we draw the diagram. This shows the observer standing a distance away from a building, which is an unknown height, h. This is what we're looking for, and we know that the distance between him and the base of the building is 300 feet, and the angle that he's looking up at is 36 degrees. Okay, so since we know the leg that's next to our angle, or the adjacent one, and we're looking for the opposite one, which is h, this tells us that we need to use the tangent function to find this. So the tangent of 36 is equal to h over 300. Find the tangent of 36 in our calculator is 0.7265. Set up our proportion is equal to h over 300. Cross multiply gives us that h is whatever 0.7265 times 300 is. That gives us that h is approximately 217.95 feet. Okay. One other thing that we need to note, and I've mentioned it several times in what we were talking about, especially with the 30, 60, 90 triangle, the sine of an angle is equal to the cosine of its complement. That means that if you take the angle measure and subtract from 90, that the sine of and cosine of the other one will be exactly the same. Or if you have the cosine of an angle, it's equal to the sine of its complement. So what this means is if we use a for the angle and we use 90 minus a for the complement, then we can make this statement here. So if the sine of a is equal to 0.0736, they want to know what the value of the cosine of the complement, because that's represented as 90 minus a. Okay, since we know that one is the angle and the other is its complement, then this tells us that those two values have to be equal. So the cosine of 90 minus a, or the cosine of the complement, is the same as the sine of the angle, which is 0.0736. Okay, thank you very much. Be sure if you've got any questions that you write them down on a piece of paper right now while they're fresh in your mind. Bring them to class tomorrow, put them on the parking lot, ask them in class whatever method works best for you, and we will discuss them before we do any work with this. Thank you very much. Goodbye.